S3EEM, a flexible and user-friendly tool to assess greenhouse gases emissions in the oil and gas industry. Before starting the presentation, just a brief introduction about myself. My name is Luca Nonini. I have an academic background in the field of environmental sustainability assessment with a PhD achieved in 2021. And currently I work at the Eartha as a sustainability analyst in the field of environmental sustainability and generally speaking climate change mitigation. Before starting talking about greenhouse gases emissions inventory, I would like to introduce the Eartha company, talking about the main services, then explore what is the power of greenhouse gases emissions inventory, so what is it, why and how is carried out, and what are the main issues and problems that need to be solved. Shifting towards the S3EEM tool, I will talk about the main principle, concept and strengths and the benefit for oil and gas industry. So Eartha is an innovative consultancy company that carries out analysis and research activities in the field of environmental sustainability for the oil and gas industry. And our services are mainly related to carbon footprint of services, products, organizations, as well as complete life cycle assessment of product and services, sustainability reporting and calculations of emissions, carbon dioxide emissions in compliance with the new CBAM regulation that was recently introduced at the European level. When we talk about greenhouse gases emissions inventory, we mean calculation of the overall emissions associated to the company activities and processes, considering the whole supply chain, so not only the physical boundaries of the company itself, but considering also all the upstream and downstream processes in the supply chain, the value chain of the company, and generally speaking for a specific year that is 1 year. Why the greenhouse gases inventory is performed? Let's say that in the context of the recently introduced Corporate Sustainability Reporting Directive and European Sustainability Reporting Standards, especially the E1 standard related to climate change, the application of greenhouse gases protocol is mandatory. Especially the Scope 2 guidance and the corporate value chain Scope 3 accounting and reporting standard for greenhouse gases emissions. This means that in this way companies will be able to prioritize actions to identify the so-called hotspot, so the high emissions activities and processes that mostly contribute to environmental impacts in terms of carbon dioxide emissions, to define targets, so identify a roadmap for actions and accountability, driving progress towards sustainability goals and manage related risk and opportunities, and therefore optimize operations. This means application of changes and innovation for low carbon technologies and practices, while also driving market competitiveness and resilience. How the greenhouse gases emissions inventory is performed? As we can see there, we have to follow different steps. The first is the definition of the company's inventory boundaries. So we have to define what we want to include in the analysis, what we want to exclude from the analysis by taking into account the organizational boundaries, so the company itself, the physical boundaries of the company itself, and the operational boundaries. That means all other activities and processes that occur both upstream and downstream the supply chain. Then we have to identify and classify the emission sources within the previously defined boundaries according to the Greenhouse Gases Protocol guidelines. As we can see there, we can classify emission sources in three scopes. The first is related to direct emissions from sources which are owned or controlled by the company itself. For example, use of vehicles for companies' activities, fuel combustions, refrigerant gases leakage, and so on. Whereas the second and the third are related to indirect emissions, so emissions that are related to activities and processes that are not controlled or owned by the company. The second specifically is related to the generation of purchased energy, electricity, steam, heat, whereas the third is related to sources that occur outside the company's organizational boundaries, so upstream and downstream activities in the value chain of the company. This is just a representation of what I have previously defined. So we have to define the organizational boundaries, which include Scope 1 and Scope 2 emissions, and then the operational boundaries, including the Scope 3 emissions. All these scopes define the inventory boundaries, which are at all the boundaries we have to include for greenhouse gases emissions estimation. After that, after defining the emission sources and classification of sources, we have to collect data as best as possible from all the emission sources, following the so-called data quality requirement. This means, for example, following the criteria of completeness, accuracy, transparency, and so on, according to the greenhouse gases protocol. Then we shift towards the emissions calculations in terms of carbon dioxide emissions, carbon dioxide equivalent from each source. This can be done in different ways. Generally speaking, in the field of modeling, we apply, as we can see in this slide, conversion factors that are called emission factors. So the carbon dioxide, the tons or kilograms of carbon dioxide equivalent are calculated for each source as the product between the activity data, for example, the amount of fuel that is used for in the combustion process for generation of electricity, with an emission factor that expresses the amount, the carbon dioxide, the mass of carbon dioxide equivalent, carbon dioxide that is emitted into the atmosphere per unit of mass or volume of a given data. If we want to express the emissions of different greenhouse gases in terms of carbon dioxide equivalent, we include the global warming potential, which is another conversion factor that is a parameter that expresses the contribution of a given greenhouse gases compared to that of carbon dioxide. When performing the emissions inventory, we have some problems, some issues. The main of them are here summarized. So the calculation of Scope 3 emissions is particularly complex and time-consuming because a company has to take contacts with final users in the case of downstream activities, or supplier in the case of upstream, so this can be particularly complex, time-consuming. We can have incomplete or unreliable data on upstream and downstream activities due to the fact that the collection of this data, the availability of this data is not always the best, is not always done in the best, in the most accurate ways, especially as it concerns the physical quantities, the mass, the distance, and so on. So as a result, we have difficulty in assessing the total greenhouse gases emissions, so performing a complete carbon footprint of the organization itself, difficulty in identifying emissions, reduction opportunities, mitigation opportunities, so what a company can do to reduce the carbon dioxide emissions along the whole supply chain. And finally, there is a lack of transparency and accountability in the process of reporting, declaration of environmental performances and progress towards sustainability goal. So considering all these issues and problems, the solution we have identified is a new and innovative model, which is called S3EEM, which is, this means Scope 3 Emissions Estimation Tool. It's a flexible and user-friendly generalized model specifically required by VALVEcampus Association, and that this will made available to the associated companies, that allow the quantification of greenhouse gases emissions related to the whole supply chain, also allowing to solve the main issues and problem we have met in the previous slide. So generally speaking, here we have a schematization of the conceptual approach. The user has to enter the data in the model through a survey, through a questionnaire, related to both upstream and downstream activities, beside, of course, the company's activities themselves. All these data and information are then processed by the tool, which is in its current version an Excel tool, which allows the calculation of greenhouse gases emissions in the, considering the whole supply chain, providing results in terms of categories and aggregation into different scopes. So coming up to the main principles, the main concept and the strengths, we can say that the methodological approach is based on the standardized greenhouse gases protocol guidelines. The user has to enter data, to upload the data through a questionnaire, taking into account different topics. So the user is asked to answer questions about different topics, and this input data will be used to calculate the emissions, which are referred to 1 solar year. To improve the accuracy calculations, of course, besides mandatory data and information, also optional questions, optional information can be included, but at the same time, if for a given topic data are not available or data are considered to be unreadable, this topic can be excluded from the analysis. One of the main strengths of the model is that we improve the calculations, so new methodological algorithms and updated parameters are included to limit the user data collection time. For example, if physical input data are not available, an economic approach is implemented to reduce time and expenditure for the user. This means to use, for example, spend-based emission factors, which express the amount, kilograms or tons, of carbon dioxide equivalent that are emitted into the atmosphere for each euros spent in a given activity or process. So, considering this last element, why the economic approach? The economic approach has several strengths. First of all, for some activities and processes, for example, purchasing goods and services, but also, for example, waste management and so on, companies are used to manage data related to cost values, which are always available and quick and relatively easy to collect. The combination of cost data with spend-based emission factors, let's say, that represents a powerful first approximation of a company's Scope 3 emissions carbon footprint, Also because the spend-based emission factors are weighted average level of greenhouse gases emission per unit of currency, unit of expenditure data in a given activity or process. These parameters are calculated through high-level modeling, generally using the so-called input-output models. So very complex calculations are performed to produce synthesis parameters results, which can be used to calculate in a very simple way greenhouse gases emissions if amount, mass, or the mass, the distance, so let's say the quantity data are not available. So this is a very powerful element. Coming up to conclusions, what are the main benefits for the oil and gas industry? First of all, for sure, the fact that the questionnaire can be filled out by the associate on his own, even if incomplete supplier or final user data. This means to have the possibility to collect scope 2 and scope 3 emissions in a very accurate way, so calculate emissions in a very clear, transparent and accurate manner. There is reduced reliance on external expertise or extensive data collection effort and time, so this means to have more efficient and cost-effective greenhouse gases emissions assessment, process management for the whole supply chain. And last but not least, scope 3 analysis is already a preliminary form, let's say, of product carbon footprint analysis. So in this way, this preliminary version of the model can be further improved and customized to adapt to different companies' needs and to solve different problems. The presentation is finished, and I thank you all of you for the attention.